Here we have another function, y equals 2 to the x power. And so pause the video, graph these on Desmos or whatever, and see if you can describe the functions. So the first one is, again, the parent function. It passes through 0, 1, and then goes exponentially. It's exponential increase. For the second one, what does the 4 do to my coordinates? It doesn't move them at all necessarily, but you should see that it stretches. It stretches vertically by a factor of 4. 0, 1 is still, it's actually, the new coordinate is 0, 4. The original coordinate should be 1, 2. Well, it's going to be 1, 8. It's going to be stretched vertically 4 times as large. And then the one that we tend to mess up is this 4x. What that actually does is it stretches it horizontally, but it stretches it by a factor of 1/4. It actually compresses the graph, and it appears to be much narrower. It might actually appear to be taller, depending on how you look at it. So hopefully you remember that from 10th grade. All right, we're going to quickly review logs and how logarithms work, because we've been dealing with interest rates and compound formulas, and using logarithms is a much better way of solving those functions than just guessing and checking. So just to review, when you see a logarithm, every logarithm should have a base, and that base should be a positive value. To understand how a logarithm works and how it's related to an exponential function, you circle the base, raise it to the power, and it should equal the value. So a to the x power should equal y. That's how we could rewrite this. And again, that can help us because we're more familiar with exponential functions than logarithm functions. Properties of logarithms. Pause the video if you need to review these. But we're going to use these properties to quickly solve our answers. But again, if you just use the circle of logarithms, sometimes you don't even need these properties. So this first problem would be 2 to the what power is equal to 1. Well, if we know our properties, we know that anything raised to the 0 power is equal to 1. So x in this case has to equal 0. That's the first property, by the way. Log base 4 to the 9th power says 4 raised to what power is equal 4 to the 9th power. Well, if our bases are the same, we set our exponents equal. X would have to equal 9. And that is the third property right there. So pause the video, answer these questions, and then hit play when you're ready, and we'll compare our answers. I almost forgot. These are common logs, which means there's no base given. And when there's no base given, we can always assume that our base is 10. So that might be a little bit useful. All right, so hopefully you found that easy. I obviously did a lot more work than was necessary, but I like to rewrite them anyways to help me make sure I get them right. The first one should be x equals 4. There's my work to show that. Be careful with number 2. We tend to miss these. We need to rewrite 0.00001 as a fraction. Then you can count the decimals and get -5 as our answer. If you are just going to look at it, it's okay to count the decimal spaces, but make sure this decimal needs to move all the way in front of the 1. So -5 spaces. Number 3, pretty easy. Number 4, also pretty easy. Just count the zeros. Make sure you count correctly. Shouldn't be too difficult. All right, so here's a couple of examples. Hit pause and just look through them and make sure there are no issues that you have. I am going to show the answers to them. So once you hit play again, you'll see the answers pop up. All right, so I got a few seconds left in this video, but here's the idea. Showed my work. Be careful with row 19. It's where it can be a little bit tricky. By the way, that is a -3. So hopefully those made sense. If anything doesn't make sense, again, reach out to me. I can give you some more examples to show you.